Okay, so this is what you get with the Digital Bird focus motor kit. You get the custom Digital Bird focus motor shield, which has an AS5 600 encoder built on board there with the stepper driver, and your input is for the RJ45 cable. With that, you get the diametrically magnetized magnet for the back of your motor that works with the encoder. Okay. You get a small bag of screws and fixings, adjustable wing bolt, one brass insert, and the screws necessary to put it together. You get a length of 50mm carbon fibre tube for support. You get two of these cogs, which are basically a 30-tooth cog on here with a 5mm shaft, and a 12-tooth cog here as well. Now, the important thing about these cogs is they have to be 0.8 modulus gears, and the reason for that is because this is the photography standard for the belts that you get for your lenses are all 0.8 modulus, so this gear has to connect properly into here, so it has to be a 0.8 mod gear set. You should find two small bearings, and from memory those are 5x8x2 with a 5mm for the 5mm shaft. And I think that's it, other than your flat RJ45 cable. Now, what you don't get in the kit currently, because supply for me is a problem at the moment, but you can get these online and Steppers online and other places. It's a NEMA 14 stepper. It doesn't come with the cog. The cog is here still to go on. Now these come, this is a 20mm deep one. You can get smaller ones as well, but I haven't tested this yet. So for the moment and for the purposes of this exercise, we're using the 20mm deep one. Now, these NEMA 14s come with these lugs for mounting. We don't need these. They're just going to cause us to have to make everything much bigger to accommodate them. So the first step is to just take a hacksaw and just take these lugs off. We're not going to need them for any support. So you just hacksaw these lugs off your motor. Okay, so let's put that aside at the moment and have a look at the parts, plastic parts required. We have the main body here, and it's printed in two parts, so this part here needs to be super glued to this part. And you'll be pleased to hear that there are relatively few parts. This is the face part, which connects on here. That way around. You have a motor support block, and you have the back. So there are 5 plastic parts to print in all, and they're not very big, so I don't think any of them have to be printed at full 100%. I think I've printed most of these at about 35%, so there's no great load bearing requirement on them. The first thing we need to do then is to take our main body, and in your kit you should find one brass insert, and if you've built any of my components before, you'll know that I use the heat system just to press that insert into the back of there. Press it down until it's in there, and it will look like this one when it's finished. You can see. Okay, so with our sponge and our water ready, turn on my torch. Take my brass insert. Just going to heat that up. Should be hot enough. Take my part, find the hole. Press that down on there. Take the flat blade. Just press it until it is all the way home. And flush with the bottom of the part like that. And just take my sponge when I'm certain it's flat. And just some water in there and cool the part off. The next step is to glue our two parts of our main body together. Now there is a left hand and a right hand version of this, depending on which pan tilt head you build. One of them, the focus motor is mounted on the left, and the other one, which I don't have here at the moment, is on the right. So for this one, the top pan tilt head, which was the first available, when you look at the front here, this should be on the right hand side. And whichever of these parts you create, one has the hole there, one has the hole here, the opening for the gears should be on the same side as that hole. Okay, so this part needs to be glued on here like so, with the opening on the same side as the hole. And as a guide, there's a small hole in the middle here, and we take a small M1 screw from the kit and just temporarily just drop it through that hole. And it comes through like so. And then on this piece, you see there are two holes, depending on which direction you're mounting. And you can just push that over like that. And that just allows us to position that accurately while we glue it. Okay. So with that in place, and that flush at the top, you maybe just want to take a screwdriver or something and just score along the plastic to create a line where that was. Then we can take this off, and you can see just faintly the line I've just scored around there. Take some super glue and super glue this face inside of that line around here. Whoop. Now I'm ready, making sure I've got the open side towards the hole. Place that on there. Move the two parts together until they connect. And it should be flush all the way around the outside of that part. And then with that held together, we can leave that to dry. This could have all been printed as one part, but to allow for cleaner printing inside and fewer supports, I decided it was more convenient to print it as two parts. So while we're waiting for that to dry, if you look at one of these other parts, if we look at the end cap, okay, with the bird on it, and turn it around this way, you notice inside there I have a small metal disc already glued into this one. In your kit, and this isn't to be confused with the encoder magnet, because this is just a plain ordinary magnet, and I'll mark them in some way in the kit, but the magnet with the screws, as opposed to the magnet for the encoder, gets put into here, and basically we just super glue that into the back of there. Now we're not interested in its magnetic properties, it just happens to be that I have a batch of these small magnets and I wanted a small metal plate at the back of this to make smoother running for the axle for our cog. So that gets super glued in there first, and then we can take one of our small bearings and that just presses into that hole after that, like so. Okay, and all the magnet is doing, as I say, is working as a bearing, so that this, if it's wearing against anything, it's not going to be wearing against the plastic. It's going to be a smooth running bearing with a back on it. If we take a look at our cogs, in the kit you will get the two cogs, one 12 tooth, one 30 tooth, and you will get a bearing shaft like this one. Okay, so the shaft is for the larger, the 30th cog, and they have a grub screw on there. Now these can be quite a tight fit. Okay, you will have to tap these in before you tighten the grub screw. And once the grub screw is in and tightened up, you will find that it is proud of here. You may find that that starts to wear. That grub screw touches the edge of the plastic there as it turns. To that end, once okay, so once this is dried, take your second bearing and the small hole in here, place that bearing in there, just press it home. Like so. So with that done, if you take a look at our motor here, you take our small 12 tooth cog and it goes in this way around with the flat and non-tooth side down. And the distance between the top of the cog and the top of the spindle inside there should work at around about 5.2 millimeters. Now you will find probably that this is quite a tight fit onto the spindle of the motor. You will probably have to tap it to get it to go down before you put your grub screw in the side of there. The cable length here I've cut down to 60 millimeters in length, and I've provided one of these with the crimps ready for you to install the crimps onto the end of your motor, because it doesn't come supplied with anything. The other tall cog, the 30 tooth cog, you'll take your small 5mm spindle and that will go down through that cog, and again you'll find you have to tap that down to get it to go down firmly onto that cog before you wind in the grub screw on the side. So it should look like this at the end of the day. Now on this side of the cog, the distance between here and here I've got as 3.94 millimeters. So if you measure, tap that in until the bottom of that to there is 4 millimeters. The grub screw, you'll notice, I've had to sand away because otherwise it sticks out too proud and it rubs against the side of the plastic here. So once you get that in, once you've tightened the grub screw, just take a small file and just file that flat with the barrel of the cog. Okay, so with your cog on here and your motor ready with your smaller cog on here, if we look at our body, with the cable at the bottom here, simply take your motor press it home until it's all the way down inside and your cog is showing through here, and make sure it's properly home. Okay. The diametrically magnetized magnet then just gets dropped on top of the back of the spindle of the motor like so, and it just lies like that. The next step is to take our motor clamp, and it has a slot in it for the cable to go through. So that simply comes down on here. and presses home, and that holds the motor in place. Next we take our focus motor board and we can plug in, and I'll give the wiring diagram for these connections as well, but that plugs in here into the 4-port in the back of the board, and this simply comes down and the wires sit inside there, and the board should sit nice and flush like so with the RJ45 port in here, and the board shouldn't rise above the lip of the back of the casing. Okay, so with our board securely in there, we have 2 of these 2.5 cap head bolts, and these are going to go directly through the back here and through the board and through the motor support. So that just clips on there. Then we can drive these all the way through. So with our back securely fixed on, we can now take our second cog with this side down, it goes through into here. We should find it drops down quite nicely. Turns like so. Then take our back, and this side goes into the other end of the spindle. That clamps shut like so. And then you take 2 of the smaller ones, these go through here and fix in. So with that complete, all that remains to be done is to put our adjustable bolt through the bottom of here. So with our focus motor relatively complete, all that needs to be done is just test it. So if we take that on here, just tighten it up on the bottom. Plug in our RJ45. If we power on now, yeah. Okay, so here's the focus motor mounted up on the balanced pan tilt head, which is going to be coming out soon. And it is handed, I just realised at the end that I'd built the one that is handed for this pan tilt head. So I'll turn on our little digital power controller and turn on our pan tilt head. Okay. Give us a few seconds to settle, then we'll click on our out point, and let's say we'll bring the camera down like so, and we'll do a little turn that direction. And we want to change our focus, so we manually just move our focus around to where we want it to end. Complete that, and we can see our focus motor and everything else has returned to home. We hit play, and I think you can tell it's pretty silent. So that's it, that's a new focus motor, and as a bonus you get the first view of the new pan tilt head. Now this pan tilt head doesn't replace the original over-the-top pan tilt head, but it does have some features that this one doesn't have. This is a more powerful pan tilt head and more compact, but this pan tilt head is balanced on the system, so it's better used, for example, on the end of a boom arm or something of that ilk. Anyway, more of that soon. This is a new focus motor. Next up will be the new version of the video turntable. Thanks for watching.